With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. Question says, a laser light of wavelength 660 nanometer is used to weld retina detachment. If a laser pulse of width 60 ms and the power is 0.5 kilowatt is used, the approximate number of photons in the pulse are. Take the Planck's constant. H is equals to 6.62 into 10 to the power minus 34 joules second. So power of laser light used is P is equals to NHC divided by lambda T, where N is the number of photon, H is the Planck's constant, whose value is 6.62 into 10 to the power minus 34 joules second. C is the speed of light, which is 3 into 10 to the power 8 meter per second. Lambda is given as 660 nanometer, which is equals to 660 into 10 to the power minus 9 meter, and T is given as 60 meter second, which is equals to 60 into 10 to the power minus 3, and power is given as 0.5 kilowatt, which is equals to 500 watt. Now put all these values in this equation, we get 500 is equals to N into H is 6.62 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 660 into 10 to the power minus 9 into 60 into 10 to the power minus 3. Number of photon N is equals to is 10 to the power 17 into 500 into 100 into 0.06 divided by 3. So after solving this, we get number of photon used is equals to 10 to the power 20. So from the options, we can say that option number C is the correct option. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.